Hello and welcome to the Networking Lunchbox. Today we're going to look at static routing in a simplified form. Modern networks have got many different components in their networks. Routers, printers, switches, servers. Today we're just going to be looking at the routing component. How the routers know where to forward user data around the network. In this example we've got a router with two networks, network A and network B. So PCX inside network A wants to talk to PCY. So it sends that traffic towards the router. The router says, yeah, I absolutely know how to find my way to PCY because it's a directly connected network. Routers can always see networks that are directly connected to their physical interfaces. It's virtually impossible to trick a router into not being able to find its directly connected network. But what happens when that network's a little bit larger? So now we've got three routers with four network segments. So PCX still wants to talk to PCY. It sends it towards the first router on the left. But that router has no idea where network D is because it hasn't been told where it is. It doesn't understand how to get there. So let's, for the sake of this diagram, just put some arbitrary numbers as placeholders so we can navigate our way around this network. So we're going to go to the left-hand router. We're going to say, you know what, if you want to find network C, you need to go to IP address number 2 because that's a directly connected connection, so we know you're going to be able to find it. And if you want to find network D, you also need to go to IP address 2 because that's a directly connected network and that's the only way you can find it. So traffic hits the left-hand router. Sure, it knows what to do with it. It gives it to the middle router. But now the middle router has no idea where network D is, so it's unable to forward that user traffic. Now the middle router needs to find network D. It goes via IP4. And on the way back, if it wants to find network A, it goes via IP number 1. So to finish it off, the right-hand router needs to find network A via IP address 3 and network B via IP address number 3 as well. So the left-hand router has A and B directly connected and we've told it how to find C and D. The middle router has B and C directly connected, so I've told it how to find network D and A. And the right-hand router has networks C and D directly connected, so I've had to tell it how to find networks A and B. And now the traffic can flow through the routers from PCX to PCY and back again, and everybody knows how to move that data around. Now let's look at the actual command syntax itself for setting up a static route. So we're on router 1 and we're in user mode as represented by the greater than symbol. We type in enable, put in our password, and now we're at privileged exec represented by the hash symbol. So we go into configure terminal. The only way you can make changes is in global config. So now notice the prompt, router 1 config hash. This is now global config. The command we're going to type is IP space route. This is the command for setting up a static route. The first variable we need is the destination network. The second one is the subnet mask of that same destination network. The destination network and its subnet mask go together as a pair to describe network C. And we need how to get there, the next hop IP address. So we've got IP route, destination network subnet mask, and the next hop IP address. Now there are a few more options you can put on the end of this command, but as this is the basic introduction to static routes, we'll leave them for a bit later on. So back to our original diagram. Let's put a whole bunch of IP addresses on it. We've got 4 networks. So on the left-hand router, we need to be able to find network 3 and we need to be able to find network 4. So the command is IP route 192.168.3.0 255.255.250. That is the network with its mask. And how do we get there? Well, we go via the middle router, which has the address of 192.168.2.2. Then from the middle router, we need to find our way to the right-hand side of the network and the left-hand side of the network. So 192.168.4 is reachable via 3.2 and 192.168.1 is reachable via 2.1. So to finish it off, over here on the right, 192.168.1 is reachable by 3.1, 192.168.2 is reachable by 3.1. With this IP route statement, you must set a static route to an IP address that is directly on your network. You can't generate a remote network via a remote IP address. You have to actually steer it to an IP address that you can physically get to directly from your interface. So now we do the verification. The simple command, show IP route. Over on the left-hand side router, we can see we have two directly connected networks represented by the C for connected, and we have two static routes for the other two networks that are not directly connected, represented with the letter S. The middle router is the same, the far right router is the same. You can see the topology that all three routers can see all four networks and they know exactly how to move around, all based on the static routes that we did on the previous slide. Show IP route, the one wonderful command to let us know everything we need. And that's it for basic static routing. We're going to be pushing static routing a little bit further with some advanced static routing in the next video. Alright, thanks very much for watching. Remember to hit the subscribe button and that notification bell to get notified when new videos are uploaded. Thanks very much, and we'll see you in the next one.